11.6, adding and subtracting rational expressions, day 1. Our objective today is to add rational expressions with like and unlike denominators and to subtract rational expressions with like and unlike denominators. That's a tad bit misleading because day 1, pretty much we're sticking close to just the like denominators with one small variation. This is Standard Algebra 1 6.1. So just like adding and subtracting fractions, you must have a common denominator when you are adding and subtracting rational expressions. Today, they will have a common or similar denominator. So you're basically going to just get by with adding and subtracting numerators and then simplifying the expressions is what we're going to do today. Tomorrow we'll have to do a little more work. So let's just review this for regular fractions so that we don't forget and that we can apply it to these. If you had the fraction 1/3 plus 1/3, remember the denominator definitely stays the same thing, 3, and you just add the numerators. 1 plus 1 is 2, so 1/3 plus 1/3 is 2/3. But let's also think about if you're adding two fractions, the denominators are not identical, but one of them is a factor of the other. 2 goes into 4 2 times. Well, to make it have a common denominator, you have to multiply top and bottom by 2. And then you would have 1/4 plus 2/4 for a total of 3/4. Okay, so we might have to do a little bit of that today. Let's look at a couple of examples here. We'll start off simple. Similar to those, these have like denominators. So here we go. Example 1. 4b over 15 plus 16b over 15. They have the common denominator of 15. So I would go ahead and write that down because that's not going to change. Then you look at your numerators, 4b plus 16b. Well, those are like terms and they can be combined for a total of how many b's? 20. So 20b over 15. Now, just like anything else, you should always look to simplify. And 20 and 15 have a common factor of 5. Divide 5 out of both of those. You're left with 4 on the top and 3 on the bottom for a final answer of 4b over 3. Questions about that? Okay. Now, of course, they're going to get a little more complicated than just having a 15 on the bottom. So we're going to look at one that has actually a binomial on the bottom. So we're looking at this example, 7x plus 9 over x minus 3. This time we're subtracting x minus 5 over x minus 3. So the very first thing you should do, put your fraction bar and definitely put an x minus 3 on the bottom because that's not going to change, just like before. Now, I can combine the numerators by combining like terms. Don't forget, there is a subtraction in the middle on this one. So what I would do is take 7x minus x. What would we have if we combine that? 6x. And then 9 minus negative 5. So plus 14. Okay, now, before you stop, you need to see if anything can be simplified. So for the 6x plus 14, you have to try to factor out anything you can. And when we're factoring, remember the very first thing you always look for when you factor? What is that called? Greatest common factor. Is there a greatest common factor of 6x and 14? 2. So that would factor to 2 times the quantity, 3x plus 7, and since the 3x plus 7 isn't x minus 3, that won't cancel out. But here's how I would write my final answer. 2 times 3x plus 7 over x minus 3. So you basically should factor everything down to see if anything cancels out. And if it does, cancel it out. Questions about that one? Okay, we've got one more. Anybody still writing the red or blue? Okay, so let's scroll down here and get myself some space. All right, so this one you see it is a little more complicated. X plus 7 over x squared minus 6x plus 9 plus x plus 3 over x minus 3. Well, before I can decide if x minus 3 is a factor of x squared minus 6x plus 9, I'm pretty sure I need to factor that. And I'm going to do this. Hopefully you all remember this. Now, pretty sure, honestly, we could go the shortcut route, but I'm not sure you would remember it at this point. So for x squared, what two things gives me x squared? X and x. The plus in front of the 9 means the signs are going to be the same, and they're both going to be minus. So minus and minus. The factor pair of 9 that adds up to 6 would be 3 and 3. Do you see what I was talking about, the shortcut?
Yeah.
What's that thing called? Because those came out to be the same thing. Do you remember? Perfect square. Perfect square trinomial. We could have asked those 3 questions like, is the first term a perfect square? What's its square root? Last term, is it a perfect square? What's its square root? And is the middle term 2 times each of those? And it would have, but I didn't want to go that route right now. Anyway, so as you can see, x minus 3 on the right is a factor of the denominator on the left. But what's missing from the one on the right to the one on the left? What's missing? Huh? Well, yeah, parentheses, but what else is missing? Megan? Yeah, another whole set of x minus 3. So to make the denominators the same, I'm going to have to do this. Multiply top and bottom by an x minus 3. So if I do that, my rational expression on the right is going to be the same as the one on the left. So here's what's going to happen. I'm going to leave the x minus 3 and the x minus 3 factored like that on the bottom. There's no reason to put that together. But the top, in order to add this side to this side, I have got to multiply that out. There's no getting around it. So to multiply this side, who remembers what that's called? FOIL. I got to multiply an x plus 3 with an x minus 3. Now, does that ring any bells, what that might look like? Or do we need to multiply it all the way out? Jared? Yeah, it'll be a difference of squares because look at the outer inner. The outer inner will be negative 3x and positive 3x. And when I combine those together, they'll fall out, right? So when I multiply those two, I would just get x squared minus 9. Okay, so here's what has to happen at this point. So I'm going to put my equal sign down here. My denominator is going to be x minus 3 and x minus 3. Go ahead and leave it in its factored form. My numerator, and I'm noticing that this is plus, thank goodness, I want to put that in standard form. So the highest exponent on x would be squared. So I would start out with x squared. What about my x terms? What would that just be? Plus x. And then what about my constant term? I have a positive 7 and a negative 9. Negative 2. So I've taken this top. Let me go back and get rid of some of this mess. I've taken this top and I have combined x plus 7 with x squared minus 9. I've added it together, and it comes out to x squared plus x minus 2. Olivia? Because the x squared and x are two different kinds of terms. They have to be identical. And x squared is an x times an x, and x, the regular x, doesn't have that extra part. Okay? Yeah.
On the bottom,
Yeah.
when we were doing perfect squares, couldn't you just do x minus 3 with the
Exponent. We can, yeah, but let's just hold off on that. Okay, once you get it combined together, here's the last thing you got to do. We got to look and see if anything cancels. Now, on this one, kind of common sense would tell us that if you got a 2 at the end, is there any way that one of our terms is going to have a 3 in it? No. So I'm telling you right now, nothing's going to cancel, but for the sake of future problems, I'm going to show you what you should always try to do at the end. You should always take that top expression and see if it factors. And I would take this now and do this. Change it to 2 sets of parentheses. What gives me x squared? X and x. What signs are going to go in the parentheses? Positive and negative. One of each, because there's a minus in front of that 2. Factor pair of 2 that has a difference of 1. 2 and 1. Which one goes where? 2 would be the positive, 1 would be the negative. Okay. The main reason that you have to factor that at the end is there may be times where you cannot tell by common sense or obvious things that one of those on the top would be a factor with one of those on the bottom, and you'd cancel them out. Okay? So you should always go down to the factored form just in case. And then when you get done, just leave it like that. That's my answer in the box. Now, Ethan, if I wanted to change that bottom to x minus 3 quantity squared, I'd be fine with that too. Okay? You could do that. So there's a lot of factoring, there's a lot of foiling, a lot of multiplying, combining like terms. That's what's going to happen here. But I'm going to tell you today's going to be a lot easier with that than tomorrow. Because tomorrow I'm not going to have like terms, so you're going to be multiplying everything to be even getting to combine them. Okay? Today it'll be not so much.